Hello everyone, welcome back again. Now we are going to go with the contract. So we have finished with the balance. So let's check what we have written so far. As you can see, our codes are here. So with the contract, so let's go with it. This time this contract actually demonstrates a a sample implementation of the Sorbonne token for Stellar. So let's go. We are going to use, let me show that we're in contracts, yes. So we are going to use the crate again. Inside the crate we have the admin, and inside the admin we have our parentheses again. So we will have has administrator, we will have read administrator, and we will have write administrator. And we will use another crate, and inside this we have the allowance, and inside this again we have the read allowance, sorry, my bad. It will have the read allowance, and we will have spend allowance, and we will have write allowance, the codes that we have written so far. And with the another use crate, this time we will have the balance. So if you're doing the same things again and again, just to make sure that it's using the same things, we are going to go with read balance, and we are going with receive balance, and we are going to go with spend balance here. And it is done. And let's go with metadata. Use the crate for the metadata, and inside this metadata we will have read decimal, we're going to talk about it, and read name, and it will have read symbol, and it will have write metadata. So if you're in the contract part, so when we go to metadata, it will just if they will be used in there, so we won't have any errors in there. So if this use crate, and we will go with the storage types, and inside the storage types we will have the instance bump amount, and we will have instance lifetime threshold. You remember it from the balance. And right after that we are going to go with use Soran SDK, get it from the token, and inside the token it should go with self, and it should go with interface as the information we have. And then we have use Soran SDK once again. This time we will have the contract, and we will have contract implementation, and we will have the address, we will have the environment, and we will have the string. And this time we are going to use Sorbonne token SDK, and inside there will be our metadata, and inside we have the token metadata. We are going to use it later, and then again we will use this time again the Sorbonne token SDK, and we will go with token utils. Okay, so now our users are ready, and now let's go with it. First we will have a function. We will go with the check non-negative amount, and inside it there will be our amount, and it should be with 128 bits. And inside this code we will have our if this amount smaller than 0, it will give an error, it will panic with we give it with panic macro, and it will say that negative amount is not allowed, so there will be inside the amount. Okay, and inside the contract, so for the contract we are just going with this. Inside the contract we will have a public struct, and it should go with the name of token, and we will have another method. We're just going to use contract implementation, and this guy's codes again are a bit longer, so just please try to keep up with me. So we will go with the contract implementation, and let's go. First we will implement the token. As you know, we have it struck in here, so now we will go with the implementation of the token. And inside the codes, first we will have another public function. It will have the initialize. Let me check. Initialize. And inside that it will have again E as the reference of environment, and it will have the admin as the address, and the decimal with unsigned integer 32. We will have name as string, and symbol as a string once again. And inside this function we will have if has administrator, which is taking reference from E. That means we will have the error, it will panic, and it will say already registered, already initialized. So it will be better use initialize. And now we will go with yes, so let me just make it longer. Yep, now we will go with right administrator, and inside that we will have again reference E, and we will have the reference admin, and if decimal is bigger than 8 bits, it will be the maximum. So inside this again we will have our error, it will panic, and it will say decimal must fit in AU8. So, and we are done with this code. So this is the first part, this is the second part, and we will have token. And now let's go with this token. We have our file in here. Okay, good. So let's copy and paste it for now, for the time being. Alright, so let's go, and we will write the metadata, and inside the metadata we will have reference E, we will have token metadata, and inside this token metadata we will have the decimal, we will have the name, and we will have the symbol. Okay, so this part is done, and let's go with another public function. And inside this public function, we are going to use the mint section. So we are going to be minting. And again, we have our e by using with the reference environment to this time not from this time to address, and the amount again should be with 128 bits. And let's go with this one. What do we have inside? We will have check non-negative amount, and inside that we have the amount, and we are going to have a new variable, and it should have the read administrator as a reference e, and we will go on, and with the admin it will require authentication, and we will just finish with it, and we will go with again e-storage because it should store everything inside, and inside the storage we will store the instance, and we will go with extend TTL, and inside the extend TTL it should go with instance threshold and instance bump account. Let me just close it with semicolon, and we will have another function, and in this function we will set an admin, and again it will have our e taking reference from the environment, and we will go with new admin, and it will have their address, and inside this function we will have again the admin variable. It will read from the administrator again with the reference of e, and again it will require a password, and we will have it again stored, and inside the storage we will have the instance, and we will have the extend TTL once again, and inside TTL we will have the instance lifetime threshold and instance bump amount once again. And then another thing that we are going to add is write administrator, and we will have the code written with again reference from e and reference from new admin, and we will use the token utils. It should create a new token util with the reference from taken e, and inside that it will go with events, and it will go with setAdmin, and inside the setAdmin we will have two arguments, admin and new admin. This is the part. So let me just crack this like this. Yes. Okay. Now we will move on with the contract implementation. So we have another contract implementation, and inside this we will go with the implementation again directly, implementation of the token, and we will use it as the interface, and interface for token, And inside this code we will have a function called allowance, and this allowance should consist again with e environment, and it will have from address and spender again as the address, and it will return with 128 bits. And inside this function we will have the storage again. We will have it stored once more, and with the instance. And again, as you can guess, we will go with the extend TTL, and inside this we will have again the same things. Inside pop amount, and we will go with read allowance, and in this read allowance we will have the go part. We will go with e again from spender dot amount. So this is how it will go. Okay. Now we are still inside the token, and we will go with another function. This time it will be the approve. Again, it should consist e as reference of environment from address, and spender should be the address once again, and there should be an amount with I want 128-bit and expiration ledger, and it should be U32. And inside this code, what do we need to have is from require authentication, and what do we do next? We check non-negative amount as the amount, and after that we will have it stored. So what do we have inside the store? Again, the instance, and we will have the extend TTL once again, and we will have the same things inside again, set threshold and instance bump amount. And one last thing is to write allowance. Again, we will have the reference from e from clone. So as you know, in Rust we can just clone everything. Spender, we should clone the spender as well to use it, and we will have the amount, and we will have the expiration ledger, and inside we will use the token utils, and we will have the new e, and also we will have the events, and we will have the approval. And what should it improve? It's from, its spender, its amount, and its expiration ledger. So as you can see, it gets 4 arguments inside. Yes, this is that. And we have another function again, and this is what we call a balance function. And inside the balance function, we will have the reference e again, and we will have e. Let's go with e, and then we will have the environment. Yes. And we will have the ID as address, and we will have we will return as I128, and inside this function we will have again the storage. We will store everything, as you can see. We will have the instance, and we will have the extend.ttl, and inside we have the again instance lifetime threshold and instance bump amount, and right after that we will have the spend balance. Inside we will have the E again, so if it's spend balance, and we will have from.clone, and sorry, before that let's go with read balance. So in read balance we will have reference E, and we will have the ID. Okay, and let's go with transfer. In transfer we have the E again as the environment, we have from as the address, we have to as the address, and we have the amount as I128, and inside this function this time we will have from require authentication. Again, we need the passwords and everything, and we will check the non-negative amount as an argument, and we will again store it with its instance and with its extend.ttl. So in the extend.ttl again we will have instance threshold and instance bump amount, and we will go with spend balance this time. In transfer we will have the reference E, from clone, and amount, and we will have the receive balance, and inside the receive balance we will have reference E again. We will have this time to.clone, so, and then we will have the amount that we send, and we will use the token utils, and inside the token utils it will have new again as reference E. We will have events, and this time we will have transfer. Inside transfer we will say from, to, an amount. It takes 3 arguments, and this will be done. And also we will go with function TransferFrom. We go with E as the environment, we go with the spender as the address, and from as the address, to as the address, and amount as again 128 bytes. So inside this, what should we have? We should have the spender again with the password, it is important, and again we will have check non-negative amount as the amount, and right after that we will have the e-storage, and we will go with the instance once again, and we will go with the extend.ttl, just like this. Let me just copy and paste, it will be the same thing. And this time in the TransferFrom we are going to use spend allowance again as reference as E, from clone, and spend run amount, and then we will have spend balance, and here again we will have the reference E, we will have from clone once again, and we will have the amount, and for receive balance it should be in here, yes. With the receive balance we will have reference E again, this time to clone, and amount once again so it doesn't change, and then we will use token utils, and in token utils we will have a new token util as reference from E, and we will have events, and we will transfer from to an amount. Yeah, and what we need to do, we need to store them, so we will go with as E storage once again, and it should store this information. Let's get this one. And so we minted, we transferred it, now we need to burn. Again, so if we go with E with environment, from address amount I122, and inside this code we need to have from, again required authentication. Again, it needs the authentication to make it more secure. And after that, what do we need to do is the checking the amount again as the amount, and we are just going to use the same again. So let's go, and right after that what we need to do is using spend balance, and it should have the reference E from clone and the amount. Also we will use token utils again to finish it. In token utils it will have a new token util by taking reference from E, and we will have events, and this time we will have burn, and what we will burn from and amount. Okay, so this is the part that go with it. Now we have the BurnFrom function. We are finished with this. So TransferFrom, BurnFrom, and again inside we will have E as the environment, spender as the address, from the address, and amount should be in size I128, and inside the code this time we should go with spender and require authentication once more to make it more secure, and again we will check everything to see it's correct or not. Let's go like this, and this time what do we use is, what are we going to use is spend allowance. We will have a reference from E, we will go with from clone, we will go with spender and amount, and also spend balance, again we will have the reference from E. We will be doing with the from clone as usual, and we will need the amount. And lastly, token utils. And in token utils we will have a new token util by using reference E. We will have the events, and we will burn again what will burn from and amount. So this is it, and let's go with fn decimals. So we talked about decimals, so we have to add it. E from env, and it should return u32. This is what we ask, and inside that we need to have read decimal as a reference from E, and we need another function, it has name function, and we will go with env again, and it should return a string, and inside the string it should go with read name, and again with reference from E. And lastly, one last thing that we have, and this is our last function. It will be, as you can guess, the symbol function, and inside we go with the symbol function with env once again, and it should return the string, and inside the string it should have the read symbol. Yes. And guys, that's it for the time being for contracts. So this part was also, took longer than I expected, but we need to use everything without any faults. So thank you so much. See you in our next video. So we finished with balance, we finished with contract. Now we will go with the metadata. Thank you for watching. Thank you for listening. See you in the next video.